Good day. We will continue our series of challenging mathematical equations that involved basic algebra and calculus. Today we want to solve the following equation: the fraction with numerator 9 to the power x minus 16 to the power x, and denominator 12 to the power x plus 16 to the power x, equal to 3. This is a type of exponential equation that frequently appear in mathematical Olympiads around the world. We will carefully walk you through the solution, by applying basic algebraic techniques. Thank you for viewing this video. Please do not forget to like the video, and subscribe to our channel. It will help the growth of our channel. We will first try to factorize the expression at most as we can. This should normally help simplify the problem. The numerator 9 to the power x minus 16 to the power x can be expanded as 3 squares to the power x minus 4 squares to the power x. And the denominator 12 to the power x plus 16 to the power x can be expanded as the quantity 3 times 4 to the power x plus 4 squares to the power x. Using the basic properties of the exponential function, one can see that 3 squares to the power x is equal to 3 to the power 2x. 4 squares to the power x is equal to 4 to the power 2x. Similarly, on the denominator, the quantity 3 times 4 to the power x can be fully expanded as 3 to the power x times 4 to the power x. And 4 squares to the power x is equal to 4 to the power 2x, as on the numerator. We remark that on the numerator we have a difference of squares, namely, 3 to the power x square minus 4 to the power x square. Moreover, we have a common factor on the denominator, 4 to the power x. We know that the difference of two squares, x squares minus y square, is equal to the quantity x plus y times the quantity x minus y. We use this property to factorize the numerator as the product of the quantity, 3 to the power x plus 4 to the power x, and the quantity 3 to the power x minus 4 to the power x. Then, we use the common factor 4 to the power x to factorize the denominator as 4 to the power x times the quantity 3 to the power x plus 4 to the power x. It is clear that the common factor for both the numerator and the denominator is the quantity 3 to the power x plus 4 to the power x. We can therefore simplify our fraction by removing the common factor on both the numerator and denominator. Therefore, our simplified fraction now has numerator 3 to the power x minus 4 to the power x, and denominator 4 to the power x. All these algebraic manipulations have greatly reduced the complexity of the problem. The whole problem is therefore simplified as the equation 3 to the power x minus 4 to the power x equal to 4 to the power x times 3. We move 4 to the power x to the right hand side and obtain 4 to the power x plus 3 times 4 to the power x. We clearly see that the right hand side has a common factor, 4 to the power x. We need to factorize the right hand side of the equation. We factor out 4 to the power x and obtain the expression 4 to the power x times 1 plus 3. Consequently, our simplified equation is just 3 to power x equals 4 to the power x plus 1. Let us check if we can have integer solutions. If x is a positive integer, then 3 to the power x is odd. In fact, 3 is odd, and the product of odd integers is still an odd integer. If x is a positive integer, then 4 to the power of the quantity x plus 1 is even. This is because 4 is even, and the product of even integers is still an even integer. Given that it is impossible to have an odd integer equal to an even integer, it comes that there are no positive integer solutions to the equation 3 to the power x equal to 4 to the power of the quantity x plus 1. It is obvious that 0 cannot be a solution, because 3 to the power 0 is 1, and 4 to the power 1 is 4. Of course, 1 is different from 4. There are also no negative integer solutions to the equation 3 to the power x equal to 4 to the power of the quantity x plus 1, because an odd integer cannot be equal to an even integer. Now let us look at irrational solutions to this equation. We take the natural logarithm of both sides of the equation. Using the properties of the natural logarithmic function, the left-hand side becomes x times the natural log of 3. and the right-hand side becomes the quantity x plus 1 times the natural log of 4. This is now a simple first-order equation. We move all terms that involve x on the left-hand side and everything else is moved to the right-hand side. We factor x out on the left-hand side, and then solve for x. Finally, we find out that the unique irrational solution to this equation is the natural log of 4 divided by the quantity, the natural log of 3 minus the natural log of 4. Thanks for watching our video. Please smash the like button and subscribe to our channel if you have not yet done so. We have an extensive collection of mathematical videos covering a wide range of topics.